All right, guys, so we are doing Chapter 10, Section 1. That's the idea today. And it is dealing with area. So area, first off, what I want to know is what the heck is area? We want to talk about that. I feel that many people just kind of automatically know what I'm talking about when I say area, but some people aren't quite sure. So first off, in geometry or in life in general, there are three basic measurements that we deal with. Okay? One measurement would just be a distance. And distance is measured just as a length. So let's call that 1 inch. Okay? So I'm finding the distance from, say, that point to that point. Or I'm finding the distance from this town to that town. Or the distance across this bookshelf. Whatever the case may be. Okay? But it is measured as a length, as a distance. Area, on the other hand, is measuring how much coverage you have. Think of like a rug, all right? Area is measuring how much of the floor does that rug cover. That's area. And of course, we would use that kind of measurement if we're maybe buying paint to paint our room, okay? You don't want to buy 15 gallons of paint at 15 bucks a pop unless you actually need 15 gallons of paint because you have a ginormous room, okay? So, what does area measure? Well, let's take this 1 inch distance that I gave you. And what we're doing now is we are making a block or a square out of it. So I have 1 inch on that side, 1 inch on that side. That makes this entire thing 1 square inch. Trying to shade that without going through the blue, but apparently that's not going to work for us. Okay, but that whole block, that is 1 square inch. And so our measurement, our units of measurement are going to be square units, whatever it's being measured in, feet, centimeters, miles, whatever. Okay, but we're talking about those square units. How many of those square units fit in there? And by the way, I also want you to know that that symbol, a lot of people read that as inches squared. That's an abbreviation. That is not inches squared. Okay? It is square inches. It is square inches. That is how we say it, folks. That is how we say it. You do not walk around saying inches squared. People will look at you funny. Okay? You talk about square inches, square feet, square miles. The abbreviation is inches squared, but that's not how you say it. Okay? All right. Well, the next measurement that we will use, okay, the next measurement that we use in life would be then volume. So we've gone from a 1 dimension, just a length. Now we went to 2 dimensions, which is then area. Volume is then 3 dimensions. And so again, I'm going to take my 1 inch length, and I'm now going to make it a cube. So if this is 1 inch by 1 inch by 1 inch, then that whole cube is 1 cubic inch. And again, that is then cubic inches. Okay, that's how we measure volume. Cubic units. Okay. Now, when you guys get into physics and chemistry and things like that, you will learn that yes, there are, and you probably already know, that there are other units for volume, you know, liters and things of that nature. Well, all those liters get converted into, or can be converted into like cubic centimeters and things of that nature. Any of you who are thinking about maybe getting into the medical field, okay? A lot of things in the medical field are measured, like medicines and things like that are measured in cc's. How many cc's of this? And they're talking about in a syringe. How many cc's of this do I give to this person? cc, cubic centimeter. That's what CC stands for. Okay? So don't think that you don't need to know this if you're going into the medical field. Yes, you do, especially if you're giving me the drugs. Got it? Okay. So, those are the measurements we're dealing with. Now, today, of course, we're only dealing with area, so we're dealing with the square units. But I'm showing you this because units do matter. And I will be taking points off if you give me the improper units. If I'm asking you for area, and you tell me the area is 5 inches, I'm taking points off. Because no, it's not 5 inches, it's 5 square inches. Okay? It makes a difference. It makes a difference. All right. And so, what are we doing? Well, we are then calculating. Let me just quickly sketch a rectangle of some sort. Okay. We are literally calculating how many of those 1 by 1 blocks fit inside of a shape. That is literally what the measurement is that we're trying to calculate. Okay? We're calculating the coverage of a shape. That's what area means. Okay? Questions there? The next thing I want you to understand is that you guys already know at least one basic area formula. Okay? And the one I'm going to point out to you that you already know is the area of a rectangle. You guys, up to now, have said that the area of a rectangle is length times width. And a lot of people still use that, and it's not wrong. It is not wrong. Okay? Length and width. The issue that some students have, and I'll be honest, I was that student, you know, when I think we first learned this in like middle school or something, okay, when you first see length times width. But when I saw that, I was very confused. Well, how do you know which one's the length? How do you know which one's the width? And the teacher always said, well, it depends on how the picture's shown to you. If it's shown to you like this, then that's the length and that's the width. If it's shown to you like this, then that's the length and that. It's like, that makes no sense to me. Okay? And to this day, honestly, it still doesn't make any sense to me. Because it doesn't matter which one you call the length and which one you call the width. Okay? It doesn't matter. And so what we're going to do in now high school geometry, we're not talking about middle school math. So what we're now going to do in high school, so we are going to stop calling it length and width. We are now going to talk about it as base and height. Okay? And there is a reason for it. Essentially, the reasoning for it is that we can then equate that to other formulas. Okay? Rather than talking about 5, 6, 7 different formulas for different shapes, we can really say that, well, all of these formulas that we're talking about come from this formula. Okay? They all come from this one formula, and base and height are always talked about the same way. And what do I mean by that? Base and height are always talked about the same way. I mean that the base is always going to be a side length of whatever shape you're talking about. Always, always, always. The base is always one of the side lengths. Okay? The height could be a side length. The height could be a side length. The most important part, though, is that the height is always perpendicular to the base. If we have a shape such as, well, we're going to talk about triangles today, so let's go ahead and throw out a triangle. The base has to be a side length of our triangle. So for the sake of argument today, let's call this the base. Now, do you suppose the base always has to be on the bottom of the shape? No. It can be turned around, it can be flipped, all that sorts of stuff. Okay, but if we call that the base, the height is now going to be from this vertex perpendicular to that base. Notice the height is not a side length of our triangle. Base always has to be a side of whatever shape you're talking about. Okay? The base is a side of the shape you're talking about. The height sometimes is a side length, but it always has to be perpendicular. Okay? Base always has to be perpendicular to height. And the base is always a side length. Okay? So, are there questions over any of that information? So now looking at your official notes here for section 10.1, starting down here, they are talking about exactly what I just said. Okay? They're talking about exactly what I just said. The base is a side length of your parallelogram. The altitude, otherwise known as the height is then going to be perpendicular to that. Okay? And since we're talking about a parallelogram, that height could be measured there. It could be measured just in the middle here somewhere. They could go to maybe this vertex and measure it from there. But it's any perpendicular height between those two sides of that parallelogram, because those two sides are going to be running parallel. Therefore, their distance between them is the same regardless where you measure it. But the height always has to be perpendicular to the base. So let's take a look at this scenario, because this one some folks have a hard time visualizing why it works. Okay? Again, the base is always a side length. So this is now my base. Okay, that red segment is the base. The height, well, for the height, what they needed to do is say, all right, well, I'm going to extend out that side. They just extended out that side so that now they can drop the altitude or the height from this vertex down. Okay? That is then the height. And if you want to see it turned in a way you maybe are more used to seeing it, if you look at it like that, hopefully it becomes very clear why that's the height. Correct? I always like to think about the height, and I know this is a silly way of thinking about it, but for whatever reason it helps. It's a visual that helps. The height of a shape, if you have the shape sitting so that it's on its base, the base is on the floor, okay? So I turned it like I have this now turned. If I'm now going to slide that through a door, I told you it's a silly analogy here, but if I slide this through a door, how tall does that door have to be? That's what a base, or the height is for a shape. Okay? It has to be perpendicular to the base. So if you're sliding it on the base, how tall does the door have to be for it to pass through? That's what we're talking about. Okay? Questions on base and height and how they apply to each other? No? Okay. Then let's take a look at our first formulas here. So, starting out, we have our formula for the rectangle, which we already talked about. Remember, it used to be length and width. Now it is base times height. Okay? The nice thing is that area for a rectangle, it is the same formula for any parallelogram. Any parallelogram, it's going to be base times height. How is that possible? Well, all they're doing is they're saying, for example, down here, that parallelogram we have, what if I bring this side out and drop a perpendicular here? Well, now the area of this little triangle out here I formed is the exact same as this triangle here. And so literally, if I took this triangle and moved it over there, I end up getting a rectangle. And so again, base times height is how I would find the area. Okay? Let's take a look at example A. Please remember, the base has to be a side length of your parallelogram. The height then has to be perpendicular to that base. So, what would I use for, well, first off, we have a parallelogram. Step one, always for these problems, is write down the formula. Area equals base times height. Okay, and please, folks, use the proper letters. I don't care if you always like to write in lowercase. Tough. Now you have to write an uppercase letter. I don't care if you always like to write in uppercase letters. Tough. Now you have to write lowercase letters. A capital B and a lowercase b mean something different. Okay? They mean something different. So please write the formulas properly. So area equals base times height because we're dealing with a parallelogram. What are we going to use for our base? Why not 4.5? 4.5 is a side length. I heard something about perpendicular. What was that?
It's not perpendicular.
What's not perpendicular?
4.5 is not perpendicular to the base.
4.5 doesn't have to be perpendicular to the base. I'm saying, why can't 4.5 be the base?
It's not perpendicular to anything.
Because it's not perpendicular to anything. There isn't a perpendicular measurement. In order to have a base, I also need to have a corresponding height. And if 5 inches is my base, then 4 inches can be my height. You with me? So therefore, our area is going to be 5 times 4, which is 20. 20 what? Square inches. Yes, please say it properly. Remember, that inches squared stuff, that's just an abbreviation. That's how we abbreviate the units. We say square inches. All right, trying another one quick. Again, we have a parallelogram. So our area formula is base times height. Again, what the heck am I going to use for the base? 2 centimeters. Again, the base has to be a side length of your shape. Well, if 2 is the base, then what's the corresponding height? 3.5 has to be your height. Okay, because remember, the height has to be perpendicular to the base. I never said it had to touch the base. I said it has to be perpendicular to the base. Again, think of that little analogy of how tall does that door have to be for us to pass that parallelogram through the door. That's the height we want. Okay? So our area is going to be 2 times 3.5, which gives us 7 square centimeters. Any questions so far on the first 2 examples? Then let's take a look at this one here. For this third one, they're asking us to find a missing dimension. They want us to find the length of DE. If you have a calculator handy, please grab it. We might need it today. So DE is this length right here, from D to E. It looks to me like that is going to be a height, correct? Well, what is the corresponding base for that height? AB, or 9.4, right? Yeah. AB is then the corresponding base for the height we're looking for. So that means if I plug into a formula for a parallelogram, area equals base times height, I don't know the area, but I do know the base is 9.4, but sadly, I don't know the height either. So can I do anything with that? No. Nope, nope. Okay, so I can't do anything with that formula. But you know what? They give me other dimensions here. So maybe we can solve for the area first. If I know the area, I can solve for h, my height. Right? So let's take a look at the diagram. Am I given another base? Yes, I am. DA is a base because it's a side length of my parallelogram. Do I have a then corresponding height to that base? 9 inches. That segment FC is perpendicular to line segment DA. They are perpendicular, so I can use those as a base and a height. Well, again, that then means that my area is base times height. So my area is 13 times 9. So someone with a calculator, what is our area? 117 square inches. Okay, well, that's my area. Great, so that means I can take that number, 117, and plug it in for A into the previous formula. Why can I do that? Well, because it's the same shape. Just because I'm using a different base and a different height, should the area of my shape change? No. Think of a rug on the floor. If I call one length the length and one side the width, is that going to change if I change what I call them? No. The area is the same of the rug. So I have 117 equals 9.4 times h. Some of you are already ahead of me here. We know we have to divide by 9.4. And so what do we get for that height? We have to round to the nearest tenth, they tell us, right? 12.4. Is that what it rounds to? 12.4? 12.4. And so that means, and I'm using the language that they have here, they want us to find DE. So therefore DE equals 12.4 inches. And now, why am I not using square inches here?
It's not there.
Right, this is a length, it's not the area. Absolutely. Again, units matter in this section, guys. Got to make sure you give me the proper units. All right, I know we're running short on time, but I do want to show one more formula. Again, this is one you guys already know. Go to the back side of your notes. On the back side of your notes, we're talking about the area of a triangle. Now again, why do I want to change the language of a rectangle from length and width to base and height? Because of this right here. If I wanted to find the area of this parallelogram, the area of that parallelogram is base times height. That's what we did on the front side. Area equals base times height. But if I take that and say, all right, well, wait a minute, let's cut it in half. And if I only want the area of that half of it, well, what's the shape of that? It's a triangle, and I said I wanted half of it. And so that right there is where I get the equation for a triangle. The area of a triangle is very literally 1/2 the area of a parallelogram. Okay? And so the area of a triangle is 1/2 base times height. And so looking at, let's just do a quick one here. What's the area of this triangle? Well, first off, area is 1/2 base times height. Always write down the formula first. What are you going to use for the base? 1 foot? Okay. And that has to be a side of our triangle, right? All right. What are you then going to use for your height? 5 inches. Okay, it doesn't have to be a side length, right? Height does not have to be a side length, but it does have to be perpendicular. The problem here is, folks, the answer is not 1 square foot. The answer is not 2.5 square feet. You cannot take feet and inches in the same formula. Always convert to the smaller unit. Always convert to the smaller unit. So how many inches are in 1 foot? So this is 12 inches. So therefore, our area is going to be 1/2 times 12 times 5. And I strongly suggest doing math in your head when you can. This is a good example of that. Make your life easy, folks. What's 1/2 of 12? So now we now have 6 times 5. So guess what our area is? 30 square inches.